The other thing I often think about is the build feedback loop, which is rapidly changing when it comes to how we build with AI coding assistance. So when you're building a lot of applications, one of the biggest risks is customer acceptance, right? A lot of startups struggle not because we can't build whatever we want to build, but because we build something and it turns out nobody cares. And so for a lot of the way I build startups, especially applications, less so deep tech, less so technology startups, but definitely application startups, is we often build software. So there's an engineering task, and then we will get feedback from users, and there's a product management task. And then we'll go back, then based on the user feedback, we'll tweak our views on what to build, go back to write more software, and we go around this loop many, many times, iterate toward product market fit. And it turns out that with AI coding assistance, which Andre talked about as well, rapid engineering is becoming possible in a way that just was not possible. It's becoming much more feasible. So the speed of engineering is going up rapidly, and the cost of engineering is also going down rapidly. This changes the mechanisms by which we drive startups around this loop. When I think about the software work that I do, I maybe put it into two major buckets. Sometimes I'll build quick and dirty prototypes to test an idea. You say, build a new customer service chatbot. Let's build an AI to process legal documents or whatever. Build a quick and dirty prototype to see if we think it works. The other type of software where I do is maintain production software, maintain legacy software, but these massive production-ready code bases. Depending on which analyst report you trust, it's been hard to find very rigorous data on this. When writing production quality code, maybe we're 30 to 50% faster with AI assistance. Hard to find a rigorous number, maybe. Feels plausible to me. But in terms of building quick and dirty prototypes, we're not 50% faster. I think we're easily 10 times faster, maybe much more than 10 times faster. And there are a few reasons for this. When you're building standalone prototypes, there's less integration with legacy software infrastructure, legacy data needed. Also, the requirements for reliability, even scalability, even security are much lower. And I know I'm not supposed to tell people to write insecure code, right? Feels like the wrong thing to say, but I routinely go to my teams and say, go ahead, write insecure code. Because if this software is only going to run on your laptop, and if you don't plan to maliciously hack your own laptop, it's fine to have insecure code, right? But of course, after it seems to be working, please do make it secure before you ship it to someone else. And like leaking PII, leaking sensitive data, that is very damaging. So before you ship it, make it secure and scalable. But if you're just testing it, it's fine. And so I find increasingly startups will systematically pursue innovations by building 20 prototypes to see what works, right? Because I know that there's some angst in AI. A lot of proof of concepts don't make it into production. But I think by driving the cost of a proof of concept low enough, it's actually fine if lots of proof of concepts don't see the light of day. And I know that the mantra, move fast and break things, got a bad rep because, it broke things. And some teams took away from this that you should not move fast, but I think that's a mistake. I tend to tell my teams to move fast and be responsible. And I think there's actually lots of ways to move really quickly while still being responsible. And in terms of the AI assistance coding landscape, I think, was it 3-4 years ago, code autocomplete, right, popularized by GitHub Copilot. And then there was a Cursor Windsurf generation of AI-enabled IDEs, which is great, use Windsurf and Cursor quite a lot. And then starting, I don't know, 6-7 months ago, there started to be this new generation of highly agentic coding assistants, including actually using O3 a lot for coding. Claude Code is fantastic. Since Claude 4 release, it's become, and ask me again in 3 months, I may use something different, but the tools are evolving really rapidly. But I think Claude Code Codex, this is a new generation of highly agentic coding assistants that is making developer productivity keep on growing. And the interesting thing is, if you're even half a generation or one generation behind, it actually makes a big difference compared to if you're on top of the latest tools. And I find my teams taking really different approaches to software engineering now compared to even 3 or 6 months ago. One surprising thing is, we're used to thinking of code as this really valuable artifact because it's so hard to create. But because the cost of software engineering is going down, code is much less of a valuable artifact as it used to. So I'm on teams where, we've completely rebuilt the code base 3 times in the last month, right? Because it's not that hard anymore to just completely rebuild the code base, pick a new data schema, is fine because the cost of doing that has plummeted. Some of you may have heard of Jeff Bezos' terminology of a two-way door versus a one-way door. A two-way door is a decision they can make. If you change your mind, come back out, reverse it relatively cheaply. Whereas a one-way door is you make a decision and if you change your mind, it's very costly or very difficult to reverse. So choosing the software architecture of your tech stack used to be a one-way door. Once you built on top of a certain tech stack, you set a database schema, really hard to change it. So that used to be a one-way door. I don't want to say it's totally a two-way door, but I find that my team will more often build on a certain tech stack. A week later, change your mind. Let's throw the code base away and redo it from scratch on a new tech stack. I don't want to overhype it. We don't do that all the time. There are still costs to redoing that. But I find my teams often rethinking what is a one-way door and what's now a two-way door because the cost of software engineering is so much lower now. And maybe going a little bit beyond software engineering, I feel like it's actually a good time to empower everyone to build with AI. Over the last year, a bunch of people have advised others not to learn to code on the grounds that AI will automate it. I think we'll look back on this as some of the worst career advice ever given, because as better tools make software engineering easier, more people should do it, not fewer. So when many decades ago, the world moved from punch cards to keyboard and terminal, that made coding easier. When we moved from assembly to higher level languages like COBOL, there are actually people arguing back then that now we have COBOL, we don't need programmers anymore. Like people actually wrote papers to that effect. But of course, that was wrong. And programming languages made it easier to code and more people learned to code. Text editors to IDEs to AI coding assistants. And as coding becomes easier, more people should learn to code. I have a controversial opinion, which is I think it's time for everyone of every job role to learn to code. And in fact, on my team, my CFO, my head of talent, my recruiters, my front desk person, all of them know how to code. And I should see all of them performing better at all of their job functions because they can code. And I think I'm probably a little bit ahead of the curve. Probably most businesses are not there yet. But in the future, I think we'll empower everyone to code. A lot of people can be more productive. I want to share with you one lesson I learned as well on why we should have people learn to do this, which is when I was teaching generative AI for everyone on Coursera, we needed to generate background art like this using Midjourney. And one of my team members knew art history, and so he could prompt Midjourney with the genre, the palette, the artistic inspiration, had a very good control over the images he generated. So we end up using all of Tommy's generated images. Whereas in contrast, I don't know art history. And so when I prompt, image generation, I could write, please make pretty pictures of robots for me, right? And I could never have the control that my collaborator could. And so I couldn't generate as good images as he could. And I think with computers, one of the most important skills of the future is the ability to tell a computer exactly what you want so that it will do it for you. And it will be people that have that deeper understanding of computers that will be able to command the computer to get the outcome you want. And learning to code, not that you need to write the code yourself, steer AI to code for you, it seems like it will remain the best way to do that for a long time. With software engineering becoming much faster,